Welcome to Sleepy Science Hub. Tonight, we're going to explore one of Earth's most profound transformations. What would happen if all the ice on our planet slowly melted away? As you settle in, let me know where in the world and at what time you're watching. Perhaps you're tucked under warm blankets while snow falls outside your window, or maybe you're listening to the gentle sound of rain against glass. Wherever you are, whatever time it is, you're exactly where you need to be. Now, get comfortable. Take a slow breath, let your shoulders drop, and let's begin this gentle journey through a world of change. Imagine, if you will, standing at the edge of a vast glacier on a quiet morning. The air is crisp and still, carrying with it the ancient scent of ice that has been sleeping for thousands of years. This ice, this frozen giant before you, holds within its crystalline structure the stories of countless winters, the breath of ancient atmospheres, and the patient dreams of a world that has been waiting. Today, something shifts. Not dramatically, not with the crash of thunder or the roar of avalanches, but with the gentlest whisper of change. The sun rises a little higher today than it did yesterday, and its rays penetrate just a fraction deeper into the surface of the ice. You might not notice it at first. This awakening is as subtle as the first breath of spring after a long winter. The ice doesn't crack or shatter. Instead, it begins to sing a soft song of transformation, one that starts with the tiniest droplets of water forming in places where solid ice has stood for millennia. Picture the vast expanse of frozen water that covers our planet. Not just the obvious places like the polar ice caps, but the hidden reserves tucked away in mountain ranges, the permafrost sleeping beneath the soil of northern lands, and the glaciers that have carved valleys and shaped continents. All of this ice, approximately 24 million cubic kilometers of it, holds within itself the potential to reshape every shoreline, every river, every lake on Earth. But this transformation doesn't happen overnight. It unfolds like a very long, very peaceful dream. In the beginning, you might notice the changes most clearly in the smallest places. A mountain stream that usually runs clear and cold now carries tiny fragments of ancient ice, each piece catching the light like scattered diamonds as they tumble downstream. The water feels different beneath your fingers, not warmer exactly, but somehow more alive, as if it's remembering what it was like to flow freely after being held in frozen suspension for so long. The glaciers themselves begin their patient retreat. If you were to visit the same glacier year after year, you would see how it draws back into the mountains like a slow tide, leaving behind smooth, polished rock that hasn't seen sunlight for thousands of years. The newly exposed stone gleams in the daylight, marked with the delicate scratches and curves that tell the story of ice's slow, powerful passage. Moss and hardy alpine plants begin to colonize these fresh surfaces, their tiny roots finding purchase in cracks and crevices, painting the landscape in soft greens and browns. The sound of this awakening is perhaps its most beautiful aspect. In the deep quiet of the mountains, you can hear the gentle trickle of meltwater finding its way through channels carved in the ice. It's not the violent rush of a flood, but rather the patient murmur of water rediscovering its path to the sea. This sound grows stronger each day, joined by the soft plinking of droplets falling from ice faces and the occasional gentle rumble as small sections of glacier settle and adjust to their changing weight. Animals sense this transformation long before humans fully comprehend its scope. Arctic foxes patrol new territories as the ice shifts, their keen senses alert to the changing landscape. Seals discover that the ice flows they've used for generations are becoming more sparse, requiring them to swim greater distances between resting places. But nature is remarkably adaptable, and these creatures adjust their patterns with the same patient grace that characterizes the melting itself. In Greenland, the massive ice sheet that has dominated the island for over 100,000 years begins its own gentle awakening. The ice here is so thick that it reaches depths of over 3 kilometers in some places, holding within its frozen layers a detailed record of Earth's climate stretching back through the ages. As the warming begins, this ice doesn't simply melt from the outside in. Instead, the transformation happens in complex, beautiful ways. Meltwater pools form on the surface like scattered sapphires, eventually finding cracks and crevices that allow them to flow deep into the heart of the glacier. These rivers within the ice carve tunnels and chambers, creating an intricate network of flowing water beneath the frozen surface. The ice sheet becomes honeycombed with these waterways, and the sound they make is like nothing else on Earth, a deep, resonant humming that seems to come from the very heart of the glacier. Standing on the surface, you might feel this vibration through your feet, a gentle reminder of the immense forces at work far below. The Antarctic ice sheet, even more massive than its northern counterpart, responds to the warming with its own unique rhythm. Here, the ice has been accumulating for millions of years, creating a frozen landscape so vast that it contains nearly 60% of all the fresh water on Earth. The transformation here is measured not in days or months, but in the slow passage of seasons and years. Ice shelves that have extended far into the Southern Ocean begin to thin and retreat, creating new bays and inlets where solid ice once stood. The wildlife of Antarctica adapts to these changes with remarkable resilience. Penguin colonies relocate as their traditional ice highways disappear, finding new routes to the sea and new places to gather and raise their young. Whales discover that they can swim into areas that were previously blocked by ice, opening up new feeding grounds and migration routes. The delicate ecosystem adjusts and rebalances itself, finding new patterns of life in this transformed landscape. As the ice melts, it releases more than just water into the world's oceans. Trapped within the ancient ice are bubbles of atmosphere from eras long past, tiny time capsules that fizz and pop as they're released into the modern air. The water itself carries minerals and nutrients that have been locked away for millennia, enriching the seas and supporting new forms of marine life. The ocean becomes more than just deeper. It becomes more diverse, more complex, more alive. The process is so gradual that if you were living through it, you might notice the changes most clearly in the rhythm of the seasons. Spring arrives a little earlier each year, lasting a little longer. The sound of flowing water becomes a more constant companion throughout the year, not just during the brief summer thaw. Rivers run fuller and stronger, carrying their increased load of meltwater toward the sea with a quiet persistence that speaks of profound change happening just beneath the surface of daily life. In the great forests of the north, trees begin to grow in places where they couldn't survive before. The warming temperatures and increased moisture create new habitats for countless species of plants and animals. What was once a landscape dominated by ice and snow gradually transforms into something more temperate, more green, more diverse. The change happens slowly enough that nature has time to adapt, to find new balances and establish new relationships between species. The Arctic Ocean, once locked beneath a permanent cap of sea ice, begins to remember what it was like to be truly open water. The ice that remains becomes thinner, more mobile, more responsive to wind and current. Ships can now navigate routes that were impassable for centuries, and marine life that was once separated by the ice barrier can now migrate freely between previously isolated populations. This awakening spreads its influence far beyond the polar regions. Mountain ranges around the world feel the touch of change as their glaciers retreat, revealing valleys and peaks that have been hidden beneath ice for thousands of years. These newly exposed landscapes become laboratories for evolution, places where life can experiment with new forms and new relationships. Alpine lakes appear where none existed before, their clear, cold waters reflecting the sky and providing habitat for species that are just beginning to discover these new homes. The transformation extends even to the microscopic level. Ancient bacteria and other microorganisms, frozen in the ice for millennia, are released back into the world as the ice melts. Most of these are harmless, and many contribute to the rich complexity of life that begins to flourish in the newly available habitats. They represent connections to Earth's distant past, living links to ecosystems that existed long before human civilization began. As we witness this great awakening, we see that it's not a story of destruction, but rather one of transformation and renewal. The ice has served its purpose, preserving and protecting the water of the world through countless cycles of climate change. Now, as it awakens from its long sleep, it returns this precious resource to the active systems of the planet, where it can nourish new life and support new forms of beauty and complexity. The pace of this change ensures that there's time for adaptation, time for the slow dance of evolution to create new balances and new harmonies. Rivers find new courses, coastlines reshape themselves gradually, and ecosystems adjust their boundaries and relationships with the patient wisdom that comes from millions of years of practice in the art of survival and renewal. In the mountains of the world, where the air grows thin and the silence runs deep, the first whispers of change begin to make themselves known. These are the places where ice has clung to rocky peaks and carved its way through ancient valleys, creating landscapes of such pristine beauty that they seem to exist outside of time itself. Here, among the glaciers and snowfields that have crowned the highest places on Earth, the transformation begins with such gentleness that you might mistake it for the natural rhythm of seasons. Picture yourself walking along a mountain trail in the early morning when the air is still cool and the light has that special quality that comes just after dawn. The path winds through meadows where wildflowers nod in the gentle breeze, and ahead of you, a glacier spreads across the valley like a frozen river caught in the middle of its flow. This glacier has been here for thousands of years, a silent witness to countless sunrises and storms. But today something is different. The ice seems to glow with an inner light, as if it's awakening from a long dream. The change begins at the edges, where the ice meets the rock and soil. Here, where the glacier's massive weight has pressed against the earth for millennia, tiny streams begin to form. These streams are barely more than threads of water at first, so small that they might go unnoticed except for the soft tinkling sound they make as they flow over pebbles and around boulders. The water is incredibly pure, filtered through layers of ancient ice and carrying with it the essence of snow that fell when your great-grandparents were children. As these streams grow stronger, they begin to carve delicate channels in the rock, creating intricate patterns that look like nature's own calligraphy written across the landscape. The sound of flowing water becomes a constant companion in these high places, a gentle music that speaks of change and renewal. It's not the harsh roar of a flood or the violent crash of breaking ice, but rather a soft symphony that seems to harmonize with the wind and the distant calls of mountain birds. The retreating glacier leaves behind a landscape that hasn't seen sunlight for thousands of years. The newly exposed rock is smooth and polished, sculpted by the patient movement of ice into flowing, organic shapes that seem almost alive. These surfaces gleam in the mountain light, reflecting the blue of the sky and the white of the remaining snow in ways that create an almost magical atmosphere. It's as if the earth itself is emerging from a long winter, stretching and yawning as it awakens to the warmth of the sun. Life responds to these changes with remarkable speed and grace. Alpine plants, hardy species that have learned to survive in the harshest conditions, begin to colonize the newly available terrain. Tiny saxifrages push their way through cracks in the rock, their delicate flowers adding spots of color to the monochrome landscape. Mosses and lichens spread across the stone surfaces, creating soft carpets that provide footing for other plants to follow. These pioneers of the plant world work together to build soil from nothing, breaking down rock and organic matter to create the foundation for future ecosystems. The animals of the mountains adapt to these changes with the same patient wisdom that has allowed them to survive in these challenging environments for countless generations. Mountain goats discover new routes through terrain that was previously blocked by ice, their sure feet finding purchase on rocks that have never before felt the weight of a living creature. Marmots emerge from their burrows to find expanded territories, new places to forage, and new vantage points from which to watch for predators. The calls of these creatures echo through the valleys, adding their voices to the growing chorus of life in these transforming landscapes. Birds, too, sense the opportunities that these changes bring. Golden eagles soar over newly exposed ridges, their keen eyes scanning for prey in territories that have only recently become accessible. Smaller birds, finches and sparrows adapted to high-altitude life, begin to nest in areas where the retreating ice has revealed protected ledges and crevices. Their songs join the sound of flowing water to create a soundtrack for transformation, a gentle reminder that life finds a way to flourish even in the most unexpected places. The lakes that form as glaciers retreat are particularly beautiful, their waters so clear and still that they seem like windows into another world. These lakes are fed by the steady flow of meltwater from above, and their surfaces reflect the surrounding peaks with such perfect clarity that it's sometimes difficult to tell where the mountain ends and its reflection begins. Fish, carried downstream from higher elevations, begin to populate these new bodies of water, creating aquatic ecosystems where none existed before. The temperature of these mountain environments changes so gradually that the shift is barely perceptible from day to day. But over the course of seasons and years, the difference becomes apparent in subtle ways. The growing season extends slightly, allowing plants to produce more seeds and build stronger root systems. Snow melts a little earlier in the spring and arrives a little later in the fall, creating longer periods when the high country is accessible to both wildlife and the occasional human visitor. Water becomes more abundant in these environments, not just from the melting glaciers, but from changes in precipitation patterns as well. The additional moisture in the air creates more frequent gentle rains and misty mornings, conditions that many mountain plants find ideal for growth. The sound of water becomes a constant presence, not just in the streams and waterfalls, but in the soft patter of rain on leaves and the gentle drip of condensation from rocks and trees. The forests that grow on the lower slopes of mountains begin to extend their reach higher up the mountainsides. Trees that once struggled to survive at the treeline find that they can now establish themselves at higher elevations, their roots finding purchase in soil that has been enriched by the retreat of the ice. These pioneer trees, often stunted and twisted by the harsh conditions, nevertheless manage to create shelter and habitat for countless other species. As the tree line moves upward, it creates a cascade of ecological changes. Animals that prefer forest habitats can now range into areas that were previously too open and exposed. Deer and elk discover new summer ranges, their trails winding through groves of young trees that are just beginning to establish themselves. The understory of these expanding forests provides habitat for smaller mammals, from shrews and voles to squirrels and chipmunks, each species finding its own niche in the changing landscape. The quality of light in these mountain environments changes as well. With less ice and snow to reflect the sun's rays, more of the light is absorbed by the rock and vegetation, creating warmer temperatures and more comfortable conditions for life. The harsh glare that once characterized these high-altitude environments is softened by the presence of more vegetation and the gentle haze of increased moisture in the air. Rivers that begin in these mountain glaciers carry the story of change down to lower elevations. The water that flows from the retreating ice is not just more abundant, but also different in character. It carries with it minerals and nutrients that have been locked away in the ice for thousands of years, enriching the soil and water systems downstream. The rivers themselves become more stable in their flow, less subject to the dramatic fluctuations that once characterized glacial-fed waterways. The seasonal rhythms of these mountain environments shift in ways that are both subtle and profound. Spring arrives earlier and more gently, without the dramatic floods that once marked the beginning of the melting season. Summer lasts longer and feels more temperate, with afternoon thunderstorms bringing regular moisture to support the expanding vegetation. Fall extends into what were once the early winter months, allowing plants and animals more time to prepare for the cold season ahead. Human visitors to these mountain environments begin to notice changes as well. Hiking trails that were once accessible only for a few months each year can now be used for longer periods. Views that were once obscured by ice and snow open up to reveal valleys and peaks that have been hidden for generations. The experience of being in these places becomes less about survival and endurance and more about appreciation and wonder. The air itself feels different in these changing mountain environments. The extreme dryness that once characterized high-altitude air is moderated by increased moisture from the melting ice and expanding vegetation. Breathing becomes easier, and the harsh bite of cold, thin air is softened by the presence of more moderate temperatures. The silence of these places, once so profound that it seemed to press against your eardrums, is now filled with the gentle sounds of life, flowing water, rustling leaves, and the calls of birds and animals. Photography in these environments captures images that seem to tell the story of change itself. The contrast between the pristine white of remaining snow and ice and the rich colors of newly exposed rock and vegetation creates compositions that are both beautiful and meaningful. The play of light and shadow across these landscapes changes throughout the day, creating an ever-shifting tableau that speaks to the dynamic nature of these transforming environments. As night falls in these mountain places, the changes become even more apparent. The air retains more warmth than it once did, making camping and overnight stays more comfortable. The sounds of night in the mountains include not just the wind and the occasional call of an owl, but also the gentle murmur of flowing water and the rustling of small animals moving through the expanding vegetation. The stars seem brighter, perhaps because the atmosphere is clearer, or perhaps because the absence of the harsh glare of snow and ice allows your eyes to adjust more completely to the darkness. Far to the north, where the world grows quiet and the horizon stretches endlessly in all directions, the Arctic Ocean begins its own gentle transformation. This is a place where silence has reigned for thousands of years, broken only by the soft whisper of wind across ice and the distant calls of seals and polar bears. Here, in this realm of eternal winter, the sea has been locked beneath a cap of ice so thick and permanent that it seemed to be as much a part of the Earth's geography as the continents themselves. Imagine standing at the edge of this frozen ocean on a day when the light has that special quality unique to the Arctic, soft and diffused, casting everything in shades of blue and silver that seem to exist nowhere else on Earth. The ice beneath your feet is not the smooth, glassy surface you might expect, but rather a complex landscape of ridges and valleys, pressure lines and leads, all carved by the patient forces of wind and current working over countless seasons. This ice tells stories in its formations, speaking of storms weathered and tides endured, of the slow dance between ocean and atmosphere that has shaped this place since the last ice age. The transformation begins so subtly that at first, you might not notice it at all. The ice that covers the Arctic Ocean is not a single, solid sheet, but rather a vast mosaic of individual flows, each one a unique creation shaped by its own journey through the polar waters. These flows bump and grind against each other with a sound like distant thunder, creating the pressure ridges and leads that give the ice pack its distinctive character. But now, something shifts in this ancient pattern. The leads, those narrow channels of open water that have always appeared and disappeared with the movement of the ice, begin to stay open a little longer. The dark water absorbs more of the sun's energy than the white ice around it, and this absorbed heat gradually warms the surrounding ice from below. The process is so gradual that it's barely perceptible, like watching a very slow sunrise that takes place over months rather than minutes. Marine life responds to these changes with a sense of wonder and opportunity. Seals, who have always been masters of finding the breathing holes and leads in the ice, discover that these openings are becoming more numerous and staying open for longer periods. They can travel greater distances underwater without the urgent need to find air, and their hunting grounds expand as fish and other prey species move into areas that were previously inaccessible. Polar bears, those magnificent wanderers of the ice, adapt their hunting patterns to accommodate the changing landscape. These powerful swimmers have always been comfortable in the water, but now they find themselves swimming longer distances between ice flows. Their thick fur and layer of fat protect them from the cold water, and their powerful strokes carry them across expanses of open ocean with the same confidence they once showed walking across solid ice. Whales sense the transformation perhaps more keenly than any other creatures. Bowhead whales, those ancient mariners who have navigated Arctic waters for millions of years, discover that they can swim through areas that were once blocked by permanent ice. Their songs, those haunting melodies that can travel for hundreds of miles through the water, now echo through newly opened channels and bays. The acoustic landscape of the Arctic changes as these passages open, creating new highways for whale communication and travel. The Arctic terns, those incredible birds who make the longest migration on Earth, flying from Arctic to Antarctic and back each year, find their northern breeding grounds subtly transformed. The areas where they once nested on ice-locked islands are now more accessible, with longer periods of open water that provide better feeding opportunities. Their chicks grow stronger on the abundant fish that thrive in the warming waters, and their cries add a new note to the Arctic's expanding symphony of life. Walruses, those gregarious giants of the Arctic, adapt to the changing ice conditions with remarkable flexibility. These social creatures have always gathered in large groups on ice floes and beaches, and now they discover new hauling grounds as the ice retreats and new beaches become available. Their tusks, evolved for hauling their massive bodies out of the water onto ice, now find purchase on rocky shores that have been revealed as the ice pulls back from the coastline. The indigenous peoples of the Arctic, whose ancestors have lived in harmony with this frozen world for thousands of years, notice the changes in ways that others might miss. The ice roads that have connected communities for generations shift their timing and routes. The hunting patterns of seal and walrus change, requiring new strategies and new understanding. But these adaptable cultures, who have survived and thrived in one of Earth's most challenging environments, adjust their ways with the same patience and wisdom that has sustained them through countless generations. Ships begin to discover routes through the Arctic that were previously impassable. The Northwest Passage, that legendary waterway that explorers sought for centuries, gradually opens to navigation. But this is not the violent breaking of ice that early explorers faced. Instead, it's a gentle clearing of the way, as if the Arctic itself is finally ready to welcome visitors. The ships that make these passages move slowly and respectfully through waters that are still home to countless creatures, their engines humming softly as they navigate channels that sparkle with reflected light. The quality of light in the Arctic begins to change as more dark water absorbs the sun's rays. The harsh glare that once reflected off endless expanses of white ice is moderated by the presence of open water and the occasional patch of exposed tundra. The light becomes softer, more nuanced, creating conditions that are easier on the eyes and somehow more welcoming to life. Photographers who venture into the Arctic find themselves capturing images of a landscape in transition, where ice and water create compositions that speak of change and continuity in equal measure. Underwater, the Arctic Ocean reveals secrets that have been hidden beneath the ice for millennia. The seafloor, once shrouded in permanent darkness, begins to receive filtered sunlight through the opening ice. Marine algae and plankton, the foundation of ocean food webs, flourish in this newly available light. These microscopic organisms create vast blooms that color the water in shades of green and blue, providing food for small fish, which in turn support larger predators. The currents of the Arctic Ocean shift as the ice retreats, creating new patterns of water movement that affect the entire polar ecosystem. Cold water that was once trapped beneath the ice now moves more freely, mixing with warmer waters from the south, and creating conditions that support a greater diversity of marine life. The ocean becomes more dynamic, more alive, as these currents carry nutrients and organisms to new areas. Ice that has existed for years, sometimes decades, finally surrenders to the warming waters. These multi-year flows, which once formed the backbone of the Arctic ice pack, break apart and melt with a sound like gentle rain. As they disappear, they release air bubbles that have been trapped in their structure for years, creating a soft, fizzing sound that speaks of ancient atmospheres being returned to the sky. The Arctic fox, with its beautiful white winter coat, discovers new hunting grounds as the ice retreats and tundra expands. These adaptable predators follow the changing landscape, their keen senses alert to new opportunities. Their dens, traditionally located on stable ice formations, are now established in areas that offer better access to both land and sea prey. Their numbers stabilize and even increase as their habitat expands and diversifies. Arctic char and other cold-water fish find that their range expands as ice-free areas become more extensive. These fish, perfectly adapted to cold water conditions, thrive in the opening channels and leads. Their populations grow, supporting not only the marine mammals that feed on them, but also the birds and other creatures that depend on healthy fish populations for survival. The midnight sun of the Arctic summer takes on new meaning as more of the ocean surface is available to absorb its continuous light. The 24-hour daylight that characterizes Arctic summers now penetrates deeper into the ocean, supporting photosynthesis at depths that were previously too dark for plant life. This extended growing season creates a cascade of biological activity that enriches the entire Arctic ecosystem. Research stations in the Arctic adapt to the changing conditions, their scientists documenting the transformation with careful attention to detail. The data they collect tells a story of gradual change, of ecosystems adapting and evolving, of life finding new ways to thrive in altered conditions. Their work helps the world understand that change, when it happens gradually, can be accommodated by the remarkable adaptability of life itself. The aurora borealis, those dancing lights that have enchanted observers for millennia, seems to take on new intensity as the Arctic atmosphere changes. The interaction between solar particles and the Earth's magnetic field creates displays that reflect off both ice and open water, doubling their beauty and creating patterns that seem to celebrate the Arctic's transformation. These lights dance across skies that are clearer and more dynamic than they have been in thousands of years. Inuit elders share stories of how their ancestors spoke of times when the ice was different, when the hunting was easier or more challenging, when the patterns of weather and wildlife followed different rhythms. These oral histories, passed down through generations, provide context for the current changes and remind us that the Arctic has always been a place of adaptation and resilience. The wisdom of these cultures, gained through thousands of years of intimate relationship with this environment, offers insights into how humans and nature can live in harmony even as conditions change. The sounds of the Arctic evolve as the ice retreats. The sharp crack of freezing ice and the grinding of floes gives way to the gentle lapping of waves against ice edges, the splash of marine mammals breathing at the surface, and the calls of birds that are expanding their range northward. It's not that the Arctic becomes noisy. It remains one of the quietest places on Earth, but rather that its silence is filled with new notes, new rhythms, new expressions of life finding its way in a transformed landscape. On the world's largest island, where ice has reigned supreme for over 100,000 years, the most profound transformation of all begins to unfold. Greenland's ice sheet is not just a frozen landscape. It is a living archive of Earth's climate history, a crystalline library where each layer tells the story of ancient winters and forgotten summers. Here, in depths that reach down 3 kilometers into the Earth, lies ice that fell as snow when woolly mammoths walked the Earth and early humans were just beginning to discover fire. Picture yourself standing on the edge of this vast ice sheet, where the frozen expanse meets the rocky coastline in a boundary that has remained unchanged for millennia. The ice stretches away from you in all directions, a white desert that seems to extend to the very edge of the world. But if you look carefully, if you listen with more than just your ears, you can sense that something ancient and powerful is beginning to stir. The ice is waking up, and with it, the stories it has kept safe for so long are finally ready to be told. The transformation begins at the surface, where the brilliant white ice has always reflected the sun's energy back into space. But now, as temperatures rise ever so slightly, the surface begins to experience something it hasn't known for thousands of years: the gentle kiss of melting. At first, it's barely noticeable. Tiny pools of water, no larger than puddles, forming in the slight depressions and valleys of the ice surface. These pools are the most beautiful shade of blue, a color so pure and intense that it seems to glow with its own inner light. These surface pools are like windows into the soul of the ice sheet. The water is so clear that you can see deep into the ice below, revealing layers and bubbles and structures that speak of countless years of accumulation. As the sun shines down on these pools, the dark water absorbs energy and begins to warm, creating the first notes in what will become a symphony of transformation that will play out over centuries. The meltwater from these surface pools doesn't simply evaporate or refreeze. Instead, it begins to find its way into the natural cracks and crevices that exist throughout the ice sheet. These pathways, some of them invisible to the eye, become rivers within the ice, carrying their liquid cargo deep into the heart of the glacier. The sound they make is unlike anything else on Earth, a deep, resonant humming that seems to come from the very foundation of the ice sheet itself. As these rivers of meltwater carve their way through the ice, they create a network of tunnels and chambers that would astound anyone who could see them. Some of these passages are narrow and winding, barely wide enough for the water to flow through. Others open into vast caverns within the ice, cathedral-like spaces where the water pools and eddies, creating acoustic chambers that amplify and transform the sound of flowing water into something almost musical. The ice that lines these tunnels and chambers is sculpted by the flowing water into forms of incredible beauty. Smooth, flowing curves that seem to have been carved by an artist's hand create surfaces that gleam and sparkle in the filtered light that penetrates from above. The walls of these ice caverns are often perfectly transparent, allowing you to see deep into the structure of the glacier and observe the layers of ice that represent different periods in Earth's history. At the base of the ice sheet, where the tremendous weight of 3 kilometers of ice meets the rocky foundation of Greenland, the effects of the surface melting begin to make themselves known. The meltwater that has traveled through the ice sheet arrives here as a gentle flood, lubricating the boundary between ice and rock. This lubrication allows the ice to move more freely, sliding toward the ocean with a motion so slow and stately that it's like watching a mountain dance. The glaciers that flow from the ice sheet toward the sea begin to respond to these deep changes. These rivers of ice, some of them over 100 kilometers long, have been flowing toward the ocean for thousands of years, but now their movement becomes more fluid, more graceful. The ice at their surfaces, which has been compressed and folded by the tremendous forces involved in glacial flow, reveals patterns and structures that tell the story of the ice sheet's internal dynamics. Where these glaciers meet the sea, they create some of the most spectacular scenery on Earth. The ice cliffs that rise from the water are often over 100 meters tall, their surfaces carved and sculpted by wind and wave into forms that seem almost architectural in their grandeur. The ice is not the pristine white that you might expect, but rather a complex palette of blues and greens and whites, each color representing different conditions of formation and compression. The calving of icebergs from these glacial fronts is a process that has always been part of the natural rhythm of the ice sheet, but now it takes on new meaning. The icebergs that break away from the glaciers are not just chunks of ice. They're pieces of ancient history, carriers of atmospheric records that date back thousands of years. As they drift away from the coast, they carry with them the stories of bygone eras, slowly melting and releasing their ancient secrets into the modern ocean. These icebergs are some of the most beautiful objects in the natural world. Their surfaces are carved by wind and wave into fantastic shapes, arches and spires and caves that seem to have been designed by some cosmic architect. The ice glows with an inner light, and the way it refracts and reflects the Arctic sun creates displays of color and brilliance that take your breath away. Some icebergs are as large as small cities, drifting majestically through the Arctic waters like frozen cathedrals set adrift. The waters around Greenland begin to change as more icebergs join the natural circulation of the Arctic Ocean. These floating mountains of ice create their own weather systems, cooling the air around them and creating mists and fogs that add to the mystical quality of the Arctic seascape. The meltwater from the icebergs is incredibly pure, having been filtered through thousands of years of ice formation, and it adds a new dimension to the Arctic marine ecosystem. Marine life around Greenland responds to these changes with remarkable adaptability. Whales that have always followed the edge of the ice now find new areas to explore as the ice retreats. The nutrient-rich meltwater from the glaciers supports blooms of phytoplankton that form the base of the marine food web. Seals and other marine mammals discover new hunting grounds and new places to rest and raise their young. The Greenlandic people, the Inuit who have called this land home for thousands of years, witness these changes with a wisdom that comes from intimate knowledge of their environment. Their traditional knowledge, passed down through generations of living in harmony with the ice and sea, provides insights into how ecosystems adapt to change. They understand that the ice has always been dynamic, always changing, and that life finds ways to thrive even as conditions shift. On the eastern coast of Greenland, where massive glaciers have carved deep fjords into the landscape, the retreat of the ice reveals terrain that hasn't been seen by sunlight for thousands of years. These newly exposed valleys and mountainsides become laboratories for life, places where plants and animals can colonize and establish new communities. The soil, enriched by thousands of years of glacial grinding, provides perfect conditions for the hardy Arctic plants that are always ready to take advantage of new opportunities. The fjords themselves become more accessible as the ice retreats, opening up waterways that were previously blocked by glacial ice. These fjords are among the most spectacular landscapes on Earth, with towering cliffs that rise directly from deep, dark water. The interplay of light and shadow in these deep valleys creates an ever-changing tableau that speaks to the power and beauty of geological forces working over vast spans of time. Birds begin to discover these newly accessible areas, with species that were previously confined to the ice-free edges of Greenland now able to explore the interior fjords and valleys. Arctic terns, those incredible long-distance migrants, find new nesting sites in areas that were previously covered by ice. Their cries echo off the cliff walls, adding a new voice to the symphony of life that is beginning to flourish in these transformed landscapes. The tundra that emerges as the ice retreats is not barren, but rather rich with potential. The soil, ground fine by thousands of years of glacial action, is full of nutrients and minerals that support rapid plant growth. Mosses and lichens are the first to colonize these areas, creating carpets of green and gray that provide the foundation for more complex plant communities. These pioneer species work together to build soil and create conditions that will support trees and shrubs as the climate continues to warm. Arctic foxes and other land mammals begin to expand their ranges as new habitat becomes available. These adaptable creatures follow the retreating ice, establishing new territories and areas that were previously inaccessible. Their presence brings new dynamics to the ecosystem, as they prey on small mammals and birds while also serving as prey for larger predators like polar bears and Arctic wolves. The summer season in Greenland becomes longer and more temperate as the ice retreats. The brief Arctic summer, when a land experiences 24 hours of daylight, extends into months that were previously dominated by ice and snow. This extended growing season allows plants to produce more seeds and build stronger root systems, gradually transforming the landscape from one dominated by ice to one where life can flourish. Rivers that have been locked beneath the ice for millennia begin to flow freely, carrying their loads of meltwater and sediment toward the sea. These rivers carve new channels through the landscape, creating habitats for fish and other aquatic life. The sound of flowing water becomes a constant presence in areas where silence once reigned, a gentle reminder of the dynamic forces that are reshaping the island. The Greenland ice sheet's retreat also reveals archaeological treasures, evidence of human habitation from periods when the climate was warmer than it has been in recent centuries. These discoveries tell the story of how human cultures have adapted to changing conditions throughout history, providing insights into the resilience and adaptability that characterize our species. Viking settlements, Inuit camps, and other archaeological sites emerge from the ice like messages from the past, reminding us that change has always been a part of the human experience. Scientists from around the world come to study these changes, establishing research stations in newly accessible areas. Their work helps us understand not just what is happening to the ice sheet, but what these changes mean for the global climate system. The data they collect is like reading the diary of the Earth itself, revealing the intimate connections between ice, ocean, atmosphere, and life. The night sky over Greenland takes on new beauty as the ice retreats. The aurora borealis, those dancing lights that have enchanted observers for millennia, seem to shine more brightly over the exposed land. The reflections of these lights in the dark water of newly formed lakes and rivers create displays that are both ethereal and profound, as if the Earth itself is celebrating its transformation. As the seasons cycle through their ancient rhythms, the changes in Greenland become more apparent. Spring arrives earlier, with the first signs of melting appearing weeks before they did in previous decades. Summer lingers longer, allowing the brief Arctic growing season to extend into months that were previously dominated by winter's grip. Fall brings new colors to the landscape as tundra plants take advantage of the longer growing season to build up their reserves for the winter ahead. The winds that blow across Greenland carry with them the sense of a changing landscape. Where once they brought only the clean, cold smell of ice and snow, they now carry hints of vegetation, of exposed soil, of life beginning to flourish in places where it was previously impossible. These winds connect Greenland to the rest of the world, carrying pollen and seeds and the chemical signatures of change to distant lands. The ice that remains on Greenland becomes more dynamic, more responsive to the changing conditions. The surface, which was once uniformly white, now shows variations in color and texture that reveal the complex processes taking place within the ice sheet. Crevasses and pressure ridges form new patterns, and the ice flows shift their courses in response to the changing conditions at their base. At the bottom of the world, where the Earth curves away into the endless white of the Antarctic continent, lies the greatest reservoir of fresh water on our planet. Antarctica is not just a land of ice, it is ice in the most profound sense. Here, beneath skies that shift between the deepest blue and the softest pearl gray, rests an ice sheet so vast and ancient that it contains within its frozen embrace nearly 90% of all the ice on Earth. This is where the true heart of our transformation beats, slow and steady, like the pulse of the planet itself. Imagine standing at the edge of this continent-sized glacier, where the ice meets the Southern Ocean in towering cliffs that rise like frozen cathedrals from the dark water. The scale of what surrounds you defies comprehension. Ice that stretches beyond every horizon. Ice that reaches depths of over 4 kilometers in some places. Ice that has been accumulating grain by grain, snowflake by snowflake for millions of years. This is not just frozen water. This is time itself made solid, a crystalline record of every breath the Earth has taken since before our ancestors walked upright. The transformation of Antarctica begins not with the dramatic collapse of ice shelves or the thunderous calving of icebergs, but with something far more subtle and profound. Deep within the ice sheet, in the darkness that has never known sunlight, the ice begins to remember what it was like to flow. The tremendous weight of the accumulated ice, pressing down through the millennia, has created pressure and temperatures that allow the ice at the base of the sheet to exist in a state between solid and liquid, like a slow-motion river flowing beneath a continent of solid ice. This movement is so gradual that if you could somehow stand on the ice and watch, you would see nothing. But the ice knows it is moving. It carries within its crystalline structure the memory of every snowflake that has fallen on the Antarctic plateau, every grain of ice that has been compressed and transformed by the unimaginable weight above. As the ice flows toward the ocean, it tells the story of Antarctica's ancient climate, whispering secrets that date back millions of years. The ice shelves that extend from the Antarctic continent into the Southern Ocean are perhaps the most spectacular features of this frozen world. These floating platforms of ice, some of them larger than entire countries, represent the meeting place between the continental ice sheet and the ocean. They are hundreds of meters thick but float like immense frozen lily pads on the surface of the sea, held in place by their connection to the grounded ice behind them and their own tremendous size. As the warming of the ocean reaches these ice shelves, the change begins at the bottom, where the ice meets the sea. The ocean water, just a degree or two warmer than it has been in previous decades, begins the slow process of melting the underside of the ice shelves. This is not the violent destruction that you might imagine, but rather a gentle erosion, like the way a warm hand might slowly melt an ice cube. The ice shelf becomes thinner, more buoyant, more responsive to the movements of the ocean beneath it. The sounds that emerge from this process are unlike anything else on Earth. Deep within the ice shelves, as they flex and adjust to their changing relationship with the ocean, there are creaks and groans and sighs that seem to come from the very soul of the continent. These sounds travel through the ice for kilometers, creating a network of acoustic communication that connects the ice shelf to the continental ice sheet behind it. It's as if Antarctica itself is learning to speak, finding its voice after millions of years of silence. Marine life in the Southern Ocean responds to these changes with the remarkable adaptability that characterizes all life on Earth. Whales that migrate to Antarctic waters to feed on the rich concentrations of krill find that their feeding grounds are expanding as the ice retreats. The giant blue whales, those magnificent leviathans that represent the largest animals ever to have lived on Earth, discover new areas where they can pursue their prey with greater freedom of movement. The krill themselves, those tiny shrimp-like creatures that form the foundation of the Antarctic food web, find that their habitat is changing in ways that create new opportunities. These remarkable organisms have evolved to live in the unique conditions created by sea ice, but they are also incredibly adaptable. As the ice conditions change, different species of krill find new niches and new areas where they can flourish, supporting the vast populations of whales, seals, and penguins that depend on them. Emperor penguins, those iconic symbols of Antarctic life, face the changes with the stoic dignity that has characterized their species for millions of years. These remarkable birds have evolved to breed on sea ice during the harsh Antarctic winter, and as the ice conditions change, they adapt their breeding cycles and locations. Their colonies shift and flow like the ice itself, finding new places to gather and raise their young. The sight of thousands of these magnificent birds moving across the ice in long, orderly processions is one of the most beautiful expressions of life's ability to adapt to changing conditions. Leopard seals, those powerful predators of the Antarctic waters, find that their hunting grounds are expanding as the ice retreats. These graceful marine mammals, perfectly adapted to life in icy waters, can now range more widely through areas that were previously blocked by permanent ice. Their haunting calls echo through the underwater canyons and channels that are opening as the ice shelves thin and retreat. The Adelie penguins, smaller but no less remarkable than their emperor cousins, establish new colonies on areas of land that are being revealed as the ice retreats. These hardy birds are incredibly adaptable, and they quickly take advantage of new nesting sites and feeding areas. Their colonies add splashes of black and white to landscapes that are slowly transitioning from pure white ice to the browns and grays of exposed rock. The Antarctic Peninsula, that finger of land that reaches northward towards South America, experiences some of the most dramatic changes on the continent. Here, where the climate is slightly milder than in the deep interior, the ice begins to retreat at a pace that is still gentle but more noticeable. Glaciers that have filled valleys for thousands of years slowly draw back, revealing landscapes that haven't seen sunlight since before human civilization began. The mountains of Antarctica, many of them buried beneath kilometers of ice for millions of years, begin to reveal their peaks and ridges as the ice sheet thins. These mountains tell the story of Antarctica's geological history, revealing rock formations and mineral deposits that provide clues about the continent's ancient past. Some of these peaks rise like islands from the sea of ice, creating nunataks, rocky outcrops that provide habitat for the few forms of life that can survive in Antarctica's harsh interior. Plant life in Antarctica, limited to a few species of mosses and lichens in the most favorable locations, begins to expand its range as more ice-free areas become available. These pioneer species, incredibly hardy and adapted to survive in conditions that would kill most other plants, slowly colonize the newly exposed soil. Their growth is measured in millimeters per year, but their presence represents the first step in the transformation of Antarctica from a continent of ice to a continent where life can flourish. The research stations scattered across Antarctica become witnesses to these changes, their scientists documenting the transformation with the dedication of explorers charting new worlds. The data they collect helps the rest of the world understand the magnitude and pace of the changes taking place. Their weather stations record temperatures that are rising slowly but steadily, and their instruments measure ice flow rates that are gradually increasing as the ice sheet responds to changing conditions. The ice cores that scientists extract from the Antarctic ice sheet are like chapters from the autobiography of the Earth. Each layer of ice contains information about the climate conditions that existed when that ice was formed, creating a record that extends back hundreds of thousands of years. As the ice sheet begins to thin and flow more rapidly, these cores become even more valuable, providing insights into how the Earth's climate system has responded to change in the past. The Southern Ocean around Antarctica begins to change as well, as the influx of fresh water from the melting ice alters the ocean's chemistry and circulation patterns. This fresh water is incredibly pure, having been locked away in ice for thousands or even millions of years. As it mixes with the salt water of the ocean, it creates new currents and circulation patterns that affect marine life throughout the Southern Ocean. Icebergs calving from the Antarctic ice shelves become more common, but even this process maintains the gentle, stately character that defines Antarctica's transformation. These icebergs are often enormous, some of them larger than entire states, but they break away from the ice shelves with a slow majesty that speaks of forces beyond human comprehension. As they drift northward into the Southern Ocean, they create their own ecosystems, supporting marine life and affecting local weather patterns. The albatrosses and other seabirds that call the Southern Ocean home find that their flight patterns and feeding areas are changing as the ice retreats. These master flyers, some of them capable of staying airborne for months at a time, adapt their routes to take advantage of new areas of open water. Their cries add to the growing chorus of life that is expanding its range as Antarctica transforms. The glaciers that flow from the interior of Antarctica toward the ocean begin to move more rapidly as the warming reaches the base of the ice sheet. This movement is still measured in meters per year rather than meters per day, but for a continent where change has been measured in geological time, even this gradual acceleration represents a profound shift. The ice flows carve new patterns in the landscape, creating crevasses and pressure ridges that speak of the dynamic forces at work beneath the seemingly static surface. The katabatic winds that flow down from the Antarctic plateau, some of the strongest and most consistent winds on Earth, begin to carry new scents and sounds as the continent changes. Where once they brought only the clean, cold smell of ice and snow, they now occasionally carry hints of exposed rock and soil, and even the faint organic scents that come from the expanding areas where life is beginning to establish itself. The midnight sun of the Antarctic summer takes on new meaning as more of the continent's surface is available to absorb its energy. The 24-hour daylight that characterizes the Antarctic summer now falls on increasing areas of dark rock and soil rather than reflective ice, creating warmer microclimates that support the expansion of plant and animal life. The interplay of light and shadow across the changing landscape creates photographic opportunities that capture the essence of a continent in transition. The aurora australis, the southern lights that dance across Antarctic skies, seem to take on new intensity and beauty as the continent changes. These spectacular displays of natural light, created by the interaction between solar particles and the Earth's magnetic field, reflect off both ice and the growing areas of open water and exposed land. The lights seem to celebrate the transformation, dancing across skies that are clearer and more dynamic than they have been in millions of years. The ice caves and tunnels that exist naturally within the Antarctic ice sheet become more numerous and more accessible as the ice begins to flow more rapidly. These natural cathedrals of ice, carved by wind and meltwater, create spaces of incredible beauty and acoustic wonder. The sound of water flowing through these ice tunnels creates music that seems to come from the heart of the continent itself, a deep bass note that resonates through the ice for kilometers. Lakes that form on the surface of the ice sheet during the brief Antarctic summer become more common and persist for longer periods. These lakes, fed by meltwater from the surrounding ice, are often a brilliant blue color that seems to glow with its own inner light. They provide habitat for microscopic life forms and create local weather patterns that moderate the harsh Antarctic climate. The geological history of Antarctica begins to reveal itself as the ice retreats from areas that have been covered for millions of years. Fossil deposits that tell the story of Antarctica's ancient past, when the continent was warm and covered with forests, begin to emerge from their icy tombs. These discoveries help scientists understand how dramatically the Earth's climate has changed over geological time and provide insights into how life adapts to changing conditions. Volcanic activity beneath the Antarctic ice sheet, previously hidden and largely unknown, begins to reveal itself as the ice thins. These volcanoes, some of them active, create their own microclimates beneath the ice, supporting unique ecosystems that exist nowhere else on Earth. The discovery of these hidden worlds adds new chapters to our understanding of life's incredible ability to adapt and thrive in even the most unlikely environments. The ice streams that carry ice from the interior of Antarctica toward the ocean begin to flow more rapidly, creating new landscapes as they carve deeper channels in the bedrock beneath the ice. These fast-flowing rivers of ice, some of them over 100 kilometers wide, represent the arteries through which Antarctica releases its ancient stores of frozen water to the sea. Their acceleration speaks of the dynamic forces that are reshaping the continent from within. As the seasons cycle through their ancient rhythms, the changes in Antarctica become more apparent to the scientists and researchers who call the continent home for part of each year. The summer season becomes longer and more temperate, with temperatures rising above freezing more frequently and for longer periods. This extended warm season allows for more extensive research activities and creates conditions that support the gradual expansion of life into previously uninhabitable areas. Around the world, where land meets sea in the eternal dance of tide and shore, a gentle transformation begins to unfold. The coastlines that have defined the edges of continents for thousands of years start to experience something that changes them as profoundly as the slow work of waves and weather, but with a pace that spans generations rather than geological ages. The ocean, enriched by the ancient waters released from melting ice, begins to rise with the slow, steady rhythm of a deep breath, reshaping every shore it touches with patient persistence. Picture yourself standing on a beach at dawn, when the light is soft and the air still carries the coolness of night. The waves roll in with their eternal rhythm, each one reaching a little higher up the sand than they did in your grandparents' time. This is not the dramatic surge of a storm or the catastrophic rush of a tsunami, but rather something far more gentle and far more profound. The slow return of water that has been locked away in ice for millennia, finding its way back to the sea that gave it birth. The change begins almost imperceptibly. The high tide mark, that line of seaweed and shells that marks the ocean's daily reach, gradually shifts inland. At first, the difference is so small that only the most careful observers notice it, perhaps a few centimeters over the course of years, marked by the gradual movement of titiline vegetation and the slow retreat of dune grasses. But this gentle advance continues year after year, season after season, with the patience of water itself. Coastal communities around the world begin to notice these changes in the intimate ways that come from living closely with the sea. Fishermen find that their boats can now reach areas at low tide that were previously too shallow to navigate. Harbors that once required careful timing to enter and exit become more accessible as the additional depth provides more margin for error. The rhythm of coastal life adjusts to accommodate these new realities, with the same adaptability that has characterized human relationships with the sea throughout history. The salt marshes that fringe many coastlines experience a renaissance as the rising waters provide them with more extensive habitat. These remarkable ecosystems, which serve as nurseries for countless species of fish and birds, expand inland as the water table rises and salt water penetrates further into coastal lowlands. The marsh grasses that thrive in the brackish water between salt and fresh spread into new areas, creating green carpets that wave gently in the ocean breeze. Mangrove forests, those incredible ecosystems that thrive where tropical rivers meet the sea, find new opportunities for expansion as rising seas provide them with more extensive intertidal zones. These remarkable trees, with their distinctive prop roots that arch into the water like natural buttresses, spread into areas that were previously too high above sea level to support their unique lifestyle. The forests become denser, more extensive, providing expanded habitat for the countless species that depend on these productive ecosystems. Sandy beaches around the world begin a slow migration inland, carrying with them the communities of plants and animals that call the shoreline home. This is not erosion in the destructive sense, but rather a natural process of adaptation as the beach profile adjusts to the new sea level. The sand doesn't disappear, it simply redistributes itself, creating new dunes and new coastal formations as the shoreline finds its new equilibrium. Sea turtles, those ancient mariners who have been navigating the world's oceans for over 100 million years, adapt their nesting behaviors to accommodate the changing coastlines. The beaches where they have traditionally come ashore to lay their eggs gradually shift, and the turtles adjust their navigation accordingly. Their nests, buried in sand that was once well above the reach of high tide, now require different placement as the water reaches further inland. Coastal birds discover new feeding opportunities as the rising waters create expanded intertidal zones rich with the marine life that forms the foundation of their diet. Sandpipers and plovers, those delicate shorebirds that seem to dance just ahead of the waves, find that their feeding grounds are larger and more productive. Their calls add to the symphony of coastal life, a gentle reminder that nature adapts to change with remarkable grace and resilience. Islands around the world experience these changes in particularly intimate ways. Low-lying coral atolls, those rings of coral that barely rise above sea level, become more dynamic as the rising waters change the relationship between land and sea. Some areas that were once dry land become partially submerged during high tide, creating new lagoons and tidal pools that support expanded marine ecosystems. The coral reefs themselves respond to the changing conditions with a remarkable adaptability that has allowed them to thrive for millions of years. As sea levels rise, corals have more vertical space in which to grow, and many reefs begin to expand upward and outward. The additional water depth provides protection from the wave action that can damage shallow reefs, creating more stable conditions for coral growth and the countless species that depend on reef ecosystems. Coastal cities around the world begin to adapt their infrastructure to accommodate the slowly rising waters. Venice, that jewel of human engineering built in harmony with the sea, experiences more frequent aqua alta, those gentle floodings that have been part of the city's character for centuries. But the Venetians, with their 1,000 years of experience living with the water, adapt with the same ingenuity that built their city in the first place. In the Netherlands, where human engineering has held back the sea for generations, the slow rise in sea level is met with characteristic Dutch innovation. The engineers who have spent centuries perfecting the art of living below sea level develop new technologies and techniques for managing the rising waters. Their polders and dikes adapt to the new conditions, and the country that has always been a testament to human ability to work with water continues to thrive. Estuaries, those productive ecosystems where rivers meet the sea, become larger and more complex as rising sea levels push salt water further upstream. These mixing zones between fresh and salt water expand, creating more extensive habitat for the specialized plants and animals that thrive in brackish conditions. The increased tidal range brings more nutrients upstream, enhancing the productivity of these already rich ecosystems. River deltas around the world experience profound changes as the rising sea level affects the balance between river sediment deposition and marine erosion. The Mississippi Delta, the Nile Delta, the Ganges Delta, all of these landscape features that have been built by thousands of years of river sediment deposition begin to adjust to new conditions. The process is slow and complex, involving the intricate interactions between freshwater flow, sediment transport, and sea level that have shaped these landscapes for millennia. Coastal wetlands, those incredibly productive ecosystems that serve as buffers between land and sea, expand their range as rising waters create new areas suitable for their specialized plant communities. Salt-tolerant grasses and sedges colonize areas that were previously too high and dry to support wetland vegetation. These expanding wetlands provide increased habitat for waterfowl and other wildlife, creating corridors that connect previously isolated populations. The fishing communities that have lived in harmony with coastal waters for generations adapt their practices to take advantage of new opportunities created by the changing conditions. Fish populations shift their distributions as water temperatures and ocean chemistry change, and experienced fishermen adjust their techniques and locations accordingly. Traditional knowledge about weather patterns, fish behavior, and ocean conditions proves invaluable in navigating these changing circumstances. Lighthouses and other coastal navigation aids find themselves in new relationships with the water they were built to guide mariners past. Some structures that once stood well above high tide now have water lapping at their foundations during spring tides. But these sturdy sentinels, built to withstand the fury of storms and the passage of time, adapt to their new circumstances with the same stoic endurance they have always shown. Coastal forests begin to change their composition as rising water tables bring salt water closer to the surface in low-lying areas. Some tree species retreat to slightly higher ground, while others that are more tolerant of salt conditions expand their range. The forest edge becomes more dynamic, creating a mosaic of different plant communities adapted to varying levels of salt tolerance. Archaeological sites along coastlines around the world begin to reveal new secrets as changing water levels expose or submerge features that have been hidden for centuries. Ancient harbors, settlements, and other evidence of human activity along former shorelines provide insights into how coastal communities have adapted to changing sea levels throughout history. These discoveries remind us that change has always been a part of the coastal experience. Surfers and other ocean enthusiasts notice subtle changes in wave patterns as the increased water depth affects how waves break along familiar coastlines. Some surf breaks become more powerful as waves have more water to work with, while others become gentler as increased depth reduces the effect of underwater topography on wave formation. The surfing community, with its intimate knowledge of ocean behavior, becomes an informal network of observers documenting these changes. Tide pools, those fascinating miniature ecosystems that exist in the intertidal zone, find new configurations as rising sea levels change the relationship between high and low tide. Some pools that were once isolated during low tide become connected to the ocean for longer periods, while new pools form at higher elevations. The communities of creatures that live in these pools, sea anemones, starfish, crabs, and countless others adapt to the new conditions with remarkable resilience. Coastal agriculture adapts to the changing conditions as rising water tables and occasional saltwater intrusion affect traditional farming practices. Farmers in low-lying coastal areas develop new techniques for managing salt-tolerant crops and implementing drainage systems that can handle occasional flooding. Traditional knowledge about farming in challenging conditions proves invaluable in developing sustainable approaches to agriculture in changing coastal environments. Migratory birds that depend on coastal habitats for feeding and resting during their long journeys find that their traditional stopover sites are changing. Some roosting areas that were once reliably above high tide become submerged during spring tides, forcing the birds to find new resting places. But the expanding wetlands and salt marshes provide new opportunities, and the birds adapt their migration routes accordingly. The rhythm of coastal life itself begins to change as communities adapt to the new relationship between land and sea. Traditional activities like beachcombing, clam digging, and gathering seaweed adjust to new tidal patterns and new shoreline configurations. Children growing up in coastal communities learn to read the signs of this changing environment, developing an intuitive understanding of the new rhythms that govern the interface between land and sea. Shipping and maritime commerce adapt to the new conditions as deeper water in previously shallow areas opens up new navigation routes while requiring adjustments to existing port facilities. Harbor masters and pilots develop new expertise in navigating channels that have been deepened by rising sea levels, and port authorities invest in infrastructure that can accommodate both the new water levels and the ships that take advantage of them. Coastal ecosystems demonstrate the remarkable interconnectedness of marine and terrestrial environments as the rising waters create new pathways for the exchange of nutrients, organisms, and energy between land and sea. Fish that spawn in freshwater rivers find that the transition zone between salt and freshwater has moved upstream, affecting their reproductive cycles and the development of their young. These species adapt with the flexibility that has allowed them to survive countless environmental changes throughout their evolutionary history. The sound of the coast itself changes as rising waters create new acoustic environments. The crash of waves against cliffs sounds different when the water is deeper, and the gentle lapping of water against sandy shores changes pitch and rhythm as the beach profile adjusts. Coastal communities that have lived with the music of the sea for generations gradually become accustomed to these new melodies, finding comfort in the eternal rhythm of water meeting land, even as the details of that interaction evolve. In the great cities of the world that have grown up along coastlines and rivers, where millions of people have built their lives in harmony with the water, a new chapter begins to unfold. These urban centers, from ancient ports that have watched over harbors for thousands of years to modern metropolises that glitter with lights reflected in dark water, find themselves adapting to a world where water plays an even more intimate role in daily life. The transformation is not sudden or violent, but rather like the slow change of seasons, requiring the same patient adaptation that has always characterized human civilization's relationship with the natural world. Imagine walking through the streets of a coastal city on a quiet morning, when the air still carries the salt scent of the sea and the light has that special quality that comes from being reflected off water. The buildings around you tell the story of generations of people who chose to make their lives near the water, drawn by the opportunities for trade, transportation, and the simple beauty of watching ships come and go from distant lands. Now, these same streets are beginning to experience something new, a gentle integration with the rising waters that speaks not of crisis, but of adaptation and renewal. The ancient city of Venice, that masterpiece of human engineering and artistic vision built in harmony with the sea, becomes a model for how urban environments can gracefully accommodate rising waters. The Venetians, with their 1,000 years of experience living with acqua alta, those gentle floodings that have always been part of the city's rhythm, find that these events become more frequent but no less manageable. The city's network of canals, bridges, and elevated walkways, originally designed to work with the water rather than against it, proves its wisdom as water levels gradually rise. The morning routine in Venice evolves to include checking the tide tables with the same casual attention that others might give to the weather forecast. Cafe owners in St. Mark's Square set up their tables with the practiced ease of generations, knowing exactly which areas will remain dry during high tide and which might experience the gentle overflow that has always been part of the piazza's character. The tourists who come to experience this unique city find that the acqua alta, rather than being an inconvenience, adds to the magical quality of a place where water and architecture dance together in perfect harmony. In Amsterdam, another city built in intimate partnership with water, the network of canals that has defined the city's character for centuries takes on new significance. The Dutch, with their legendary expertise in water management, approach the rising sea levels with the same innovative spirit that has allowed them to live below sea level for generations. The city's canal houses, with their distinctive architecture designed to accommodate seasonal flooding, prove to be perfectly adapted to the new conditions. The houseboats that line Amsterdam's canals find themselves in an ideal position to adapt to rising water levels. These floating homes, already accustomed to rising and falling with the water, simply adjust their mooring lines and continue to bob gently at their berths. Their residents, who have always lived in harmony with the water's rhythms, become inadvertent pioneers in a new way of urban living that works with water rather than fighting against it. London, where the Thames has been the lifeblood of the city for 2 millennia, experiences the rising waters as a return to a more intimate relationship with the river that created it. The Thames Barrier, that marvel of engineering that has protected the city from storm surges, takes on new importance as water levels gradually rise. But the city that survived the Blitz and countless other challenges approaches this new reality with characteristic British adaptability and ingenuity. The ancient wharves and docks along the Thames, many of them now converted to restaurants, galleries, and residential areas, find that their relationship with the water becomes more immediate. Some establishments that were once well above high tide discover that spring tides now lap at their terraces, creating opportunities for waterfront dining that brings diners closer to the river than ever before. The gentle slap of water against old stone and timber adds a new note to the urban symphony. In New York City, the harbor that has welcomed immigrants and commerce for centuries begins to play a more prominent role in daily life. The Staten Island Ferry, that stalwart connector of communities, finds that its route passes through waters that are deeper and more extensive than before. The ferry terminals adapt to the new water levels with the same practical efficiency that has always characterized New York's approach to infrastructure challenges. The subway system, that underground network that has moved millions of New Yorkers for over a century, incorporates new water management systems designed to work with occasional flooding rather than simply trying to keep every drop of water out. The city's engineers, building on decades of experience managing water in an urban environment, develop innovative approaches that turn potential challenges into opportunities for improved urban design. Boston, built on a series of peninsulas and filled-in bay areas, rediscovers its maritime heritage as rising waters reveal the original geography that shaped the city. The harbor islands that have always been part of Boston's identity become more prominent features in the urban landscape, and ferry service to these islands becomes a more integral part of the city's transportation network. The city's relationship with Boston Harbor, temporarily diminished during the industrial era, strengthens as clean water and expanded waterfront access create new opportunities for recreation and commerce. In San Francisco, the bay that gives the city its character becomes an even more dominant feature of urban life. The fog that rolls in from the Pacific Ocean carries with it the scent of a bay that is deeper and more extensive than before. The Golden Gate Bridge, that iconic span that connects the city to the world beyond, watches over waters that reflect more light and support more marine life as the ecosystem adjusts to the new conditions. Miami, a city that has always lived intimately with water, approaches the rising seas with the tropical adaptability that has characterized South Florida for generations. The Art Deco buildings of South Beach, with their distinctive architecture and vibrant colors, find that occasional flooding during the highest tides becomes part of the neighborhood's character rather than a problem to be solved. Restaurants and shops adapt by creating elevated seating areas and installing stylish water management features that enhance rather than detract from the area's aesthetic appeal. The Everglades, that vast wetland ecosystem that defines South Florida's relationship with water, expands as rising sea levels push fresh and salt water further inland. This expansion creates new opportunities for wildlife and recreation, as the boundaries between urban and natural environments become more fluid. Alligators and manatees, those iconic species of Florida waters, find expanded habitat that brings them into closer but still harmonious contact with human communities. In Tokyo, a city built on a delta where multiple rivers meet the sea, the rising waters are met with characteristically Japanese precision and innovation. The city's sophisticated flood control systems, already among the most advanced in the world, evolved to accommodate higher baseline water levels while maintaining their ability to handle storm surges and heavy rainfall. The result is a city that maintains its function and beauty while adapting to new hydrological realities. The traditional Japanese gardens scattered throughout Tokyo incorporate water features that respond to the changing urban water table. Koi ponds and water gardens that have been maintained for generations find that they require less supplemental water as the natural water table rises. The sound of flowing water, always an important element in Japanese garden design, becomes more prominent as streams and fountains work with rather than against the natural flow of water through the urban environment. Sydney, with its spectacular harbor that defines the city's identity, experiences the rising waters as an enhancement to its already stunning waterfront. The Opera House, that architectural masterpiece that seems to float on the harbor's edge, finds that high tides bring the water closer to its base, creating an even more intimate relationship between the building and the sea that inspired its design. The harbor ferries that connect the city's waterfront communities adjust their schedules and routes to accommodate the new water levels with the same efficiency that has characterized Sydney's harbor transportation for over a century. Coastal walkways and promenades in cities around the world evolved to accommodate occasional flooding during the highest tides. These adaptations often enhance rather than diminish the urban experience, creating opportunities for waterfront dining, floating markets, and other activities that bring residents and visitors into closer contact with the water. The elevated boardwalks and flexible infrastructure that emerge from these adaptations become models for urban design that works with natural processes rather than fighting against them. Public transportation systems in coastal cities develop new approaches to dealing with water that emphasize resilience and adaptability. Subway tunnels incorporate improved drainage and waterproofing, while elevated train lines and light rail systems provide alternatives during periods of high water. Ferry systems expand to provide redundant transportation options, creating networks of water-based transit that reduce dependence on street-level infrastructure during flooding events. Urban parks and green spaces in coastal cities become more valuable as they adapt to serve as temporary water storage areas during periods of high tide. These spaces, designed with permeable surfaces and strategic landscaping, provide recreational opportunities during dry periods while serving as managed flood zones when needed. The result is urban green space that serves multiple functions, providing both recreational and environmental benefits to city residents. The restaurant and hospitality industries in coastal cities develop new approaches that turn occasional flooding into unique dining experiences. Waterfront establishments create elevated dining areas and floating platforms that allow them to operate regardless of water levels. Some restaurants embrace the occasional flooding as part of their character, offering special, high-tide menus and creating dining experiences that celebrate the intimate relationship between city and sea. Art and culture in coastal cities respond to the changing relationship with water through new forms of expression that celebrate rather than fear the rising seas. Public art installations incorporate water features that respond to tidal changes, creating dynamic sculptures that change throughout the day. Street art and murals reflect themes of adaptation and resilience, while theaters and concert halls use the sounds of water as part of their acoustic design. Real estate markets in coastal cities adjust to the new realities with characteristic flexibility. Properties that were once considered vulnerable to flooding are redesigned and retrofitted to work with water rather than against it. Floating homes, elevated structures, and buildings designed to accommodate periodic flooding become desirable features rather than liabilities. Architects and builders develop new expertise in creating structures that are both beautiful and resilient. Children growing up in these evolving coastal cities develop an intuitive understanding of living with water that will serve them throughout their lives. They learn to read tide tables as naturally as others learn to read clocks, and they develop swimming skills that are both recreational and practical. Schools incorporate water safety and marine ecology into their curricula, creating generations of urban residents who understand and appreciate their intimate relationship with the sea. The technology sector in coastal cities develops innovative solutions for urban water management that become models for cities around the world. Smart sensors monitor water levels and automatically adjust infrastructure systems, while mobile apps provide real-time information about flooding and transportation alternatives. These technological solutions enhance rather than replace traditional approaches to living with water, creating hybrid systems that combine human wisdom with digital innovation. Healthcare and emergency services in coastal cities adapt their protocols to account for more frequent but predictable flooding events. Hospitals and clinics develop procedures for maintaining operations during high water events, while emergency responders train specifically for water-related situations. The result is improved overall emergency preparedness that benefits all residents, not just those directly affected by flooding. Urban agriculture in coastal cities evolves to take advantage of the higher water table and occasional flooding. Rooftop gardens and vertical farms reduce dependence on distant food sources while providing fresh produce for urban markets. Aquaponic systems that combine fish farming with vegetable production become more common, creating closed-loop food production systems that work with rather than against urban water cycles. The insurance and financial sectors develop new approaches to risk assessment that recognize the predictable nature of gradual sea level rise. Rather than treating flooding as a catastrophic event, these industries create products that help property owners adapt to changing conditions. The result is more stable and affordable insurance markets that support rather than hinder urban adaptation to rising seas. Community organizations in coastal cities become focal points for sharing knowledge and resources related to living with water. Neighborhood groups organize flood preparation activities, share information about local water conditions, and coordinate mutual aid during high water events. These grassroots networks strengthen community bonds while building resilience that benefits entire neighborhoods. The shipping and maritime industries that have always been important to coastal cities adapt to deeper harbors and expanded port facilities. Container ships and cruise vessels can access ports that were previously limited by shallow water, while smaller boats and water taxis become more important parts of urban transportation networks. The result is enhanced economic opportunity that builds on rather than replaces traditional maritime commerce. Across the vast tapestry of Earth's ecosystems, from the deepest forests to the highest mountains, from sprawling grasslands to intimate wetlands, life begins to dance to new rhythms as the planet's water cycle transforms. This is not the harsh disruption that might be imagined, but rather something more like the gentle transition between musical movements in a symphony. The same underlying themes continue, but with new variations, new harmonies, and new opportunities for the complex web of relationships that connect all living things. In the great temperate forests of the world, where ancient trees have stood sentinel for centuries, the changing patterns of water availability create subtle but profound shifts in the forest community. The massive sequoias of California, those cathedral-like giants that have witnessed the rise and fall of human civilizations, find that their growing season extends slightly longer each year. The fog that has always nourished these coastal forests becomes more frequent and persistent as increased evaporation from from the warming ocean creates more moisture in the atmosphere. The understory of these forests responds to the additional moisture with an explosion of growth that enriches the entire ecosystem. Ferns unfurl their fronds in areas that were previously too dry to support them, creating carpets of green that provide habitat for countless small creatures. Mosses and lichens, those patient pioneers that can survive in the harshest conditions, spread across tree trunks and forest floors, adding layers of texture and color that make the forest feel more alive, more vibrant, more welcoming to the diverse communities of plants and animals that call it home. Birds that have always migrated through these forests find that the timing of their journeys can be more flexible as the extended growing season provides food sources for longer periods. Warblers and vireos that once had to time their migrations precisely to coincide with insect emergences discover that the buffet of forest insects now lasts weeks longer than before. Their songs fill the forest with music that extends well into what were once the quiet months of early autumn. In the tropical rainforests, those engines of biodiversity that generate much of the planet's oxygen and house the majority of Earth's species, the increased moisture in the atmosphere creates even more lush conditions. The emergent layer of the forest, where the tallest trees reach toward the sky, experiences more frequent gentle rains that support the extraordinary diversity of epiphytes, orchids, bromeliads, and ferns that make their homes in the forest canopy. The rivers that wind through these tropical forests carry more water throughout the year, creating expanded habitat for the incredible diversity of freshwater fish that form the foundation of rainforest food webs. Amazon river dolphins find that their range expands as previously shallow tributaries become navigable year-round. These intelligent marine mammals, perfectly adapted to life in muddy river water, explore new territories with the curiosity that has always characterized their interactions with their complex riverine environment. Jaguars, those magnificent predators that rule the rainforest floor, adapt their hunting patterns to take advantage of the expanded wetland areas that develop as river levels rise. These powerful swimmers have always been comfortable in water, and now they find that their aquatic hunting skills become even more valuable as their territory becomes more water-rich. Their territories expand to include areas that were previously too dry to support the abundant prey populations that jaguars require. The prairie grasslands of the world experience perhaps the most dramatic positive transformation, as increased moisture allows these ecosystems to reach their full potential. The Great Plains of North America, which have always been subject to cycles of drought and abundance, find that the abundance phase of the cycle becomes more consistent and longer-lasting. The native grasses that define these ecosystems, big bluestem, buffalo grass, and dozens of others, respond to the increased moisture by growing taller and more densely than they have in decades. Bison, those icons of the American prairie, benefit enormously from the improved grassland conditions. The herds that have been carefully restored to small portions of their original range find that the carrying capacity of the land increases dramatically. The calves born into these improved conditions grow stronger and healthier, and the adult animals develop the massive size and robust health that characterize their ancestors. Their grazing patterns create the complex mosaic of grassland habitats that support hundreds of other species. Prairie dogs, those social rodents whose complex underground cities form the foundation of grassland ecosystems, expand their colonies into areas that were previously too dry to support their extensive burrow systems. Their towns become larger and more complex, providing expanded habitat for the burrowing owls, black-footed ferrets, and other species that depend on prairie dog colonies for shelter and hunting opportunities. The mountain ecosystems of the world experience their own unique transformation as treelines shift upward and alpine environments become more hospitable to life. In the Rocky Mountains, the tree line that has marked the boundary between forest and alpine tundra for thousands of years begins to creep slowly up the mountainsides. Engelmann spruce and subalpine fir establish new populations at elevations where they could never survive before, creating forest habitat in areas that were previously too harsh for tree growth. Alpine wildflowers, those hardy plants that have learned to complete their entire life cycle during the brief mountain summer, find that their growing season extends by weeks or even months. The result is spectacular displays of color that last far longer than before. Indian paintbrush, mountain aster, and alpine forget-me-nots create carpets of color that attract pollinators from the lower elevations and support expanded populations of the hummingbirds and butterflies that depend on high-altitude nectar sources. Mountain goats and bighorn sheep discover expanded territories as areas that were previously snow-covered year-round become accessible for grazing during extended summer seasons. These sure-footed climbers explore new cliff faces and ridgelines, their populations growing as their habitat expands. The sight of these magnificent animals silhouetted against mountain skylines becomes more common as they range into previously inaccessible areas. In the world's wetlands, those incredibly productive ecosystems that serve as nurseries for countless species, the expanded water availability creates conditions that support explosive growth in biodiversity. The Okavango Delta in Africa, already one of the world's most spectacular wetland systems, becomes even more extensive as increased water flow supports larger seasonal floods. The result is expanded habitat for elephants, hippos, and the countless species of birds that depend on wetland ecosystems. Migratory waterfowl experience a renaissance as wetland habitats become more extensive and more reliably available. Ducks, geese, and swans find that their traditional flyways now include many more suitable stopover sites. The breeding populations of these species increase dramatically as more nesting habitat becomes available and food sources become more abundant and reliable. Amphibians, those sensitive indicators of ecosystem health, experience a remarkable recovery as increased moisture creates ideal conditions for their complex life cycles. Salamanders that require specific combinations of moisture and temperature find that their habitat expands significantly. Tree frogs discover new breeding pools in forest areas that were previously too dry to support temporary ponds. The chorus of frog songs that fills spring and summer nights becomes richer and more complex as new species join the symphony. The desert ecosystems of the world experience perhaps the most surprising transformation as increased atmospheric moisture creates more frequent but still gentle rainfall events. The Sonoran Desert of Arizona and Mexico, already remarkably diverse for a desert ecosystem, blooms with new vigor as rare rain events become slightly more common. Desert wildflowers that normally bloom once every few years now display their spectacular colors more frequently, creating temporary gardens that support expanded populations of desert pollinators. Saguaro cacti, those iconic sentinels of the Sonoran Desert, respond to the improved moisture conditions by growing more rapidly and reaching larger sizes. These giant cacti, which can live for over 150 years, provide critical habitat for desert birds and mammals. As they grow larger and more numerous, they support expanded populations of Gila woodpeckers, elf owls, and the other species that depend on saguaro cavities for nesting sites. Desert springs, those oases that have always been critical to desert ecosystems, become more reliable and more extensive as groundwater levels rise. The vegetation around these springs expands, creating green islands in the desert that support remarkably diverse communities of plants and animals. Desert bighorn sheep, always dependent on reliable water sources, find that their range expands as more springs become year-round water sources. In the world's rivers and streams, the increased water flow creates improved habitat for countless species of fish and other aquatic life. Salmon runs that have struggled in recent decades due to low water levels experience a revival as streams maintain higher flows throughout the year. The spawning grounds in high mountain streams become more accessible and more suitable for successful reproduction. Trout populations flourish in streams that maintain cooler temperatures due to increased flow and more consistent water levels. The deep pools that trout require for overwintering become more common and more stable, supporting larger and healthier fish populations. Fly fishermen find that their favorite streams offer better fishing opportunities throughout longer seasons. River otters, those playful indicators of healthy aquatic ecosystems, expand their ranges as more waterways provide suitable habitat. These charismatic mammals require clean water, abundant fish populations, and suitable denning sites, all of which become more available as river ecosystems improve. Their presence indicates the overall health of riparian ecosystems that support countless other species. The seasonal rhythms that have governed life on Earth for millions of years begin to shift in subtle but significant ways. Spring arrives with more reliable moisture, allowing plants to begin growing earlier and continue growing longer. The synchronization between flowering plants and their pollinators adjusts gradually, with most species maintaining their critical relationships while taking advantage of extended growing seasons. Migration patterns of birds and mammals adjust to accommodate longer growing seasons and more reliable water sources. Some species that traditionally migrated long distances find that they can survive in areas where they previously could not, leading to shorter migration routes and reduced energy expenditure. This allows these species to put more energy into reproduction and raising young. The pollinator networks that connect flowering plants across vast landscapes become more robust as flowers bloom for longer periods and nectar sources become more reliable. Bees, butterflies, and other pollinators find that their foraging seasons extend significantly, allowing them to build larger stores of food and support larger populations. The result is more effective pollination for wild plants and agricultural crops alike. Predator-prey relationships adjust to new conditions as prey populations increase in response to improve habitat conditions. Wolves, bears, and other large predators find that their prey species are more abundant and healthier, leading to more successful hunting and reproduction. The top predators that regulate ecosystem balance become more effective at maintaining the complex relationships that keep ecosystems healthy. Plant communities begin to shift their distributions as species that were previously limited by moisture availability expand their ranges. Forests extend into areas that were previously too dry for tree growth, while grasslands become more lush and support greater diversity. The boundaries between different ecosystem types become more fluid as species explore new territories and establish new communities. Soil organisms, those countless invisible workers that form the foundation of terrestrial ecosystems, flourish in the improved moisture conditions. Earthworms, soil bacteria, fungi, and myriad other decomposers become more active and more abundant, improving soil health and nutrient cycling. This enhanced soil biological activity supports more productive plant communities, creating a positive feedback loop that benefits entire ecosystems. The phenology of flowering, fruiting, and other seasonal events gradually shifts as organisms adapt to new moisture patterns and extended growing seasons. Cherry trees bloom earlier, but for longer periods. Fruit trees produce larger crops over extended harvest seasons. Seed production increases across virtually all plant communities, providing more food for seed-eating animals and ensuring better plant reproduction. Symbiotic relationships between species become stronger and more complex as improved conditions allow for more specialization. Mycorrhizal fungi that partner with plant roots expand their networks, improving nutrient exchange and plant health. Nitrogen-fixing bacteria in soil and root nodules become more active, improving soil fertility naturally. Fire regimes in many ecosystems shift as increased moisture reduces the frequency and intensity of wildfires while promoting the growth of fire-adapted vegetation. This creates a healthier balance between fire suppression and the natural fire cycles that many ecosystems depend on for regeneration and diversity. The acoustic landscape of natural environments becomes richer and more complex as animal populations increase and breeding seasons extend. The dawn chorus of birds becomes more varied and lasts longer into the morning. Evening sounds include the calls of more species as animals remain active for longer periods. The natural soundscape that humans have always found calming and restorative becomes even more diverse and beautiful. Nocturnal animals find that extended growing seasons provide more food sources during their active periods. Bats discover more insects to hunt, while owls and other night hunters find more abundant prey. The night shift of ecosystem activity becomes more productive and more diverse, creating more complete utilization of available resources. Interconnections between different ecosystems become stronger as improved water availability creates corridors that connect previously isolated habitats. Riparian forests expand along streams, creating highways that allow species to move between different ecosystem types. Mountain meadows become more extensive, connecting alpine and subalpine environments more effectively. As the transformation of our planet's water systems reaches its gentle completion, a new equilibrium emerges across the Earth's interconnected systems. The atmosphere, oceans, and continents find themselves in a different but harmonious relationship, one that speaks to the planet's remarkable ability to adapt and rebalance itself over time. This is not merely a return to some previous state, but rather the emergence of something entirely new, a world where water moves more freely, life flourishes more abundantly, and the complex systems that govern our planet's climate find new patterns of stability and grace. The global circulation of the atmosphere adjusts to accommodate the changed distribution of land, sea, and ice. Weather patterns that have governed regional climates for thousands of years shift into new configurations that, while different from what came before, establish their own reliable rhythms. The jet streams that carry weather systems around the planet find new pathways as the temperature differences that drive them adjust to the altered geography of ice and water. Clouds form in new patterns as increased evaporation from the expanded ocean surface provides more moisture to the atmosphere. These clouds are not the harbingers of storms and chaos, but rather gentle, persistent formations that moderate temperatures and provide steady, nourishing rainfall to ecosystems around the world. The hydrological cycle becomes more vigorous, moving water more efficiently from ocean to atmosphere to land and back again, creating a more dynamic but stable system. The monsoons that bring life-giving rain to billions of people around the world strengthen and become more reliable as increased ocean temperatures provide more energy to drive these massive atmospheric circulation patterns. The summer rains that feed the great river systems of Asia, the Ganges, the Mekong, the Yangtze, become more dependable, supporting larger populations of both humans and wildlife. The timing of these seasonal rains remains predictable, but their abundance increases, creating conditions that support more productive agriculture and healthier ecosystems. In the vast Pacific Ocean, the circulation patterns that influence weather around the world adjust to the new thermal equilibrium. The great currents that carry warm water toward the poles and cold water toward the equator find new configurations that distribute heat more evenly around the planet. This thermal rebalancing creates more moderate temperature extremes, reducing the harsh conditions that have always challenged life in the planet's most demanding environments. The Gulf Stream, that great river of warm water that has brought temperate conditions to northern Europe for thousands of years, strengthens as increased freshwater flow from melting ice initially disrupts, and then reestablishes its circulation in a new, more vigorous pattern. The British Isles experience milder winters and more moderate summers, as this enhanced ocean circulation brings them into an even more temperate climate zone. Marine ecosystems around the world experience a renaissance as the expanded ocean provides more habitat and more stable conditions for life. The deep ocean, that vast three-dimensional habitat that represents the largest living space on Earth, becomes more accessible as surface conditions moderate and ocean circulation strengthens. Deep-sea species that have lived in the planet's most remote environments find that their habitat expands as improved circulation brings more nutrients and oxygen to the ocean depths. Coral reefs, those rainforests of the sea that support perhaps a quarter of all marine species, find new opportunities for growth and expansion. The additional water depth provides protection from the temperature extremes and wave action that can stress shallow reefs, while the improved circulation brings more nutrients to support the complex food webs that make coral reefs so incredibly diverse. New reef systems establish themselves in areas that were previously too shallow or too isolated to support coral growth. The great whales that migrate through the world's oceans discover that their ancient highways have been expanded and improved. Blue whales, those magnificent giants that represent the largest animals ever to have lived on Earth, find that their feeding grounds and polar waters are more extensive and more productive. The krill populations of these whales depend on flourish in the nutrient-rich waters created by enhanced ocean circulation, supporting larger whale populations than have existed in centuries. Seabird colonies around the world experience explosive growth as marine food webs become more productive and more stable. Albatrosses, those master ocean wanderers that can fly for months without touching land, discover that their feeding areas are more extensive and more reliable. The sight of these magnificent birds soaring over the expanded oceans becomes more common as their populations recover and grow beyond their historical numbers. Coastal wetlands and estuaries, those incredibly productive transition zones between land and sea, expand dramatically as rising sea levels create more extensive intertidal habitats. These ecosystems, which serve as nurseries for countless marine species, become more important than ever as they provide expanded breeding and feeding areas for fish, shellfish, and other marine life. The productivity of these coastal ecosystems supports larger populations of both marine and terrestrial species. River deltas around the world transform into more extensive and more productive ecosystems as rising sea levels change the balance between sediment deposition and erosion. The Mississippi Delta, the Nile Delta, the Amazon Delta, all of these landscape features that have been shaped by thousands of years of river flow, adjust to new conditions that allow them to expand and support more diverse communities of plants and animals. The Great Lakes of the world, Superior, Baikal, Victoria, and countless others, find their levels stabilizing at new highs as increased precipitation and reduced evaporation create more reliable water supplies. These freshwater seas become even more important refuges for freshwater species, many of which are found nowhere else on Earth. The expanded shorelines provide new habitat for wetland species, while the deeper water supports more robust fish populations. Groundwater systems around the world recharge more effectively as increased precipitation and reduced evaporation allow more water to penetrate the soil and replenish underground aquifers. Springs that have been dry for decades begin to flow again, creating oases of life in previously arid regions. Wells that communities have depended on for generations become more reliable and more productive, supporting stable water supplies for both human communities and natural ecosystems. The world's great forest systems expand their boundaries as increased moisture allows tree growth in areas that were previously too dry to support forest ecosystems. The Amazon rainforest spreads into areas of savanna and grassland, creating more habitat for the incredible diversity of species that make the Amazon one of the most biodiverse places on Earth. Boreal forests in Canada and Siberia extend their range northward, creating vast new areas of forest habitat in regions that were previously dominated by tundra. Agricultural systems around the world adapt to take advantage of improved water availability and extended growing seasons. Farmers discover that they can grow crops in areas that were previously too dry or too cold for agriculture, while traditional farming regions experience increased productivity as water stress decreases and growing seasons extend. The result is more abundant food production with less environmental stress, supporting both human populations and the wild species that live in agricultural landscapes. The timing of seasonal events around the world gradually shifts to accommodate longer growing seasons and more reliable water supplies. Spring arrives earlier but more gently, without the dramatic temperature swings that can stress both wild and cultivated plants. Summer lasts longer but is moderated by increased cloud cover and more frequent gentle rains. Autumn extends well into what were previously winter months, allowing plants and animals more time to prepare for the cold season. Migration patterns of animals around the world adjust to new seasonal rhythms and more abundant resources. Some species that traditionally migrated long distances find that they can survive year-round in areas where they previously had to travel to find suitable conditions. This reduces the energy cost of migration and allows these species to invest more resources in reproduction and raising young. Pollination networks become more robust and more extensive as flowering seasons extend and nectar sources become more reliable. Bees, butterflies, and other pollinators find that they can support larger populations and maintain more diverse flight patterns as flowers bloom for longer periods and in greater abundance. This enhanced pollination supports both wild plant communities and agricultural crops, creating more resilient food systems. The carbon cycle adjusts to accommodate the expanded areas of vegetation and a more vigorous growth that results from improved water availability. Forests, grasslands, and other plant communities absorb more carbon from the atmosphere as they grow more rapidly and extensively. This natural carbon sequestration helps to moderate atmospheric composition while supporting more productive ecosystems. Ocean chemistry stabilizes in new configurations as the expanded seas absorb and distribute atmospheric gases more effectively. The ocean's role as a buffer for atmospheric composition becomes even more important as the larger ocean volume provides greater capacity for absorbing and processing the chemical inputs from the atmosphere. Marine food webs adjust to these new chemical conditions, often becoming more productive and more diverse. The planet's energy balance shifts to a new equilibrium as the changed distribution of ice, water, and vegetation alters how solar energy is absorbed, reflected, and distributed around the Earth. The albedo effect, the reflection of solar radiation by light-colored surfaces, decreases as ice cover diminishes, but this is balanced by increased cloud formation and vegetation growth that moderate the temperature effects. Tidal patterns around the world strengthen as the deeper oceans allow tidal forces to operate more effectively. Coastal ecosystems that depend on tidal cycles for their functioning, salt marshes, mangrove forests, rocky intertidal zones, benefit from more robust tidal action that brings more nutrients and oxygen to these highly productive environments. Wind patterns adjust to new pressure differentials created by the changed distribution of land and water temperatures. These new wind patterns are generally gentler and more consistent than before, reducing the destructive power of storms while maintaining the atmospheric circulation that distributes heat and moisture around the planet. Sailing and wind-powered transportation become more reliable as wind patterns stabilize in their new configurations. The aurora displays at both poles become more frequent and more spectacular as changes in atmospheric circulation and magnetic field interactions create enhanced conditions for these natural light shows. The aurora borealis and aurora australis paint the polar skies with colors and patterns that reflect the planet's new electromagnetic environment, creating displays of natural beauty that celebrate the Earth's transformation. Soil formation accelerates around the world as increased moisture and biological activity break down rock more rapidly and support more active soil ecosystems. Earthworms, bacteria, fungi, and countless other soil organisms work more effectively in the improved moisture conditions, creating richer, more fertile soils that support more productive plant growth. This enhanced soil development creates a positive feedback loop that supports even more vigorous ecosystem development. The planet's magnetic field interacts differently with solar radiation as atmospheric circulation patterns change, creating subtle but measurable alterations in the magnetosphere that protects Earth from harmful cosmic radiation. These changes generally enhance the protective effect of the magnetic field, providing better shielding for both technological systems and biological processes. Volcanic activity around the world adjusts to new stress patterns as the changed weight distribution of water and ice alters crustal pressures. Most volcanic systems stabilize in new equilibria that produce gentler, more predictable eruptions that contribute to soil fertility without creating destructive explosions. The volcanic ash and gases that enter the atmosphere contribute to cloud formation and soil nutrients in ways that support rather than disrupt ecosystem development. Earthquake patterns shift as tectonic stresses adjust to new weight distributions across the Earth's surface. The gradual nature of the water redistribution allows tectonic systems to adjust slowly, reducing the sudden stress releases that create destructive earthquakes. Seismic activity generally becomes more predictable and less violent as the Earth's crust finds new equilibria. The planet's rotation subtly adjusts to the changed mass distribution as water moves from ice sheets to oceans. This adjustment is so gradual that it's barely measurable, but contributes to more stable orbital mechanics and more predictable seasonal cycles. The length of days and the timing of seasons remain essentially unchanged, but with slightly more precision and reliability. Atmospheric circulation in the upper atmosphere strengthens as enhanced surface evaporation provides more energy to drive high-altitude wind patterns. These strengthened circulation patterns improve the mixing and distribution of atmospheric gases, creating more stable atmospheric composition and better protection from solar radiation. The planet's albedo, its overall reflectivity, stabilizes at a new level that maintains thermal equilibrium while supporting more vigorous biological activity. Although ice cover decreases, increased cloud formation and vegetation growth provide alternative sources of reflection and atmospheric cooling that maintain global temperature balance. Biodiversity increases dramatically as expanded and more stable habitats support larger populations of existing species while providing opportunities for new species to evolve and establish themselves. The genetic diversity that drives evolution and adaptation increases as isolated populations reconnect and species explore new ecological niches created by the transformed environment. The water cycle becomes more efficient and more responsive as increased atmospheric moisture and expanded ocean surface area allow for more rapid and effective movement of water between different reservoirs. Droughts become less severe and less persistent, while floods become gentler and more predictable as the enhanced water cycle distributes moisture more evenly across time and space. And so we find ourselves at the end of this gentle transformation, in a world where water moves more freely, where life flourishes in ways both familiar and wonderfully new, where the ancient rhythms of our planet have found fresh expressions of their eternal themes. The Earth that emerges from this great melting is not a world diminished, but rather a world enhanced, a planet that has remembered what it means to be truly blue, truly alive, truly connected in all its myriad forms and flowing patterns. In this transformed world, the boundaries between sea and land have become more fluid, more graceful, more accommodating to the countless forms of life that depend on both domains. The rigid distinctions that once defined coastlines have softened into gradual transitions where salt marshes extend further inland, where mangrove forests create vast green tangles that breathe with the tides, where wetlands spread like fingers into the landscape, connecting distant watersheds and creating corridors for life to move freely between what were once separate worlds. The cities that have learned to live with water rather than fight against it have become more beautiful, more livable, more human in their accommodation of natural rhythms. Streets that flood gently during the highest tides have become community gathering places, where neighbors meet to wade and play in warm salt water that reflects the lights of surrounding buildings. Children grow up swimming through urban environments, as comfortable in water as on land, developing an intuitive understanding of currents and tides that connects them to the same forces that guide dolphins and whales through the open ocean. Architecture has evolved to celebrate rather than resist the presence of water. Buildings rise on graceful columns that allow water to flow freely beneath them, their foundations designed to flex and move with the gentle rhythm of the tides. Rooftop gardens capture rainwater and morning dew, creating green spaces that seem to float above the urban waterways. Glass corridors connect buildings at multiple levels, allowing residents and workers to choose whether to travel by boat along the canals below or by elevated walkway above the high tide line. The harbors of the world have become more spectacular, not less, as deeper waters allow for more magnificent ships, while gentler conditions make every voyage safer and more comfortable. Sailing has experienced a renaissance as more reliable wind patterns and calmer seas make it practical for both commerce and recreation. The horizon from any waterfront is filled with sails of every description, from massive cargo vessels that move goods around the world without burning fossil fuels to tiny pleasure craft that allow their crews to experience the pure joy of moving across the water powered only by wind and tide. Marine life has flourished beyond anything seen in recorded history. Whales, no longer confined to narrow ice-free corridors, range freely through oceans that support vast populations of the krill and fish that sustain them. The songs of humpback whales carry further through the deeper waters, creating ocean-wide networks of communication that connect whale populations across entire ocean basins. Blue whales, those magnificent giants, have returned to population levels not seen since before commercial whaling began. Their presence in the world's oceans a testament to life's remarkable ability to recover when given the opportunity. The coral reefs that ring tropical islands and continental shelves have expanded into some of the most spectacular underwater gardens ever known. Protected by deeper water from the wave action and temperature extremes that once threatened them, these living cities beneath the waves support an explosion of marine biodiversity. Divers and snorkelers find themselves swimming through underwater cathedrals where every surface is alive with color and movement, where schools of fish move like living clouds through gardens of coral that stretch beyond the range of vision. Forests around the world have reclaimed territories that have been closed to them for thousands of years. The great boreal forests of Canada and Siberia stretch now to the Arctic Ocean itself, creating vast green corridors that support wildlife migrations of unprecedented scale. Bears, wolves, and caribou move freely through forests that extend for thousands of unbroken kilometers, following seasonal rhythms that connect the deepest interior of continents to the shores of the polar sea. The Amazon rainforest has expanded beyond its traditional boundaries, reaching into areas of former grassland and savanna to create an even more vast and interconnected ecosystem. The canopy that once covered portions of South America now stretches nearly from coast to coast, supporting biodiversity that includes thousands of species unknown to science. The sound of this expanded forest is a symphony of life, bird calls, insect songs, and the rustle of leaves and trees so tall they seem to brush against the clouds themselves. Mountain ecosystems have been transformed as treelines climb ever higher, creating forests in places where only alpine tundra existed before. Valleys that were once filled with glacial ice now host meadows where wildflowers bloom in displays that would have been impossible in the harsher climate of the past. Mountain lakes, fed by gentle streams rather than dramatic glacial outflows, provide crystal-clear reflections of peaks that seem to float suspended between earth and sky. The night sky over this transformed earth blazes with auroras more frequently and more brilliantly than before. The enhanced atmospheric circulation and altered magnetic field interactions create natural light shows that dance across polar skies almost every night during the long Arctic and Antarctic summers. These displays of celestial beauty reflect off the expanded ocean surfaces and the countless lakes and wetlands that knot the landscape, creating a world where the boundary between earth and heaven seems to dissolve in curtains of shimmering light. Agriculture has been revolutionized by the reliable moisture and extended growing seasons that characterize this new climate. Farmers around the world grow crops that were once restricted to small regions, creating more diverse and resilient food systems. Traditional knowledge about working with water and weather patterns has been combined with new techniques for managing gentle flooding and seasonal water storage, creating farming systems that work in harmony with natural cycles rather than fighting against them. The deserts of the world, while still recognizably arid, bloom more frequently and more spectacularly than ever before. When the seasonal rains arrive, These landscapes transform into gardens that support expanded populations of desert wildlife. Cacti grow larger and more numerous, their flower displays supporting increased numbers of desert pollinators. Springs that were once seasonal now flow year-round, creating oases that support remarkable concentrations of life in environments that were once much more austere. Rivers run fuller and cleaner throughout the year, supporting fish populations that provide food for both wildlife and human communities. Salmon runs that had dwindled to barely sustainable levels now surge up streams in numbers that darken the water and provide food for bears, eagles, and countless other species. The sound of flowing water has become one of the most common sounds on Earth, as streams and rivers that were once seasonal now run throughout the year. In this world, the relationship between humans and the natural environment has found a new harmony. Communities around the globe have learned to read the signs of weather and water with the same skill that their ancestors once possessed, but enhanced by scientific understanding that allows for more precise prediction and preparation. Children grow up swimming before they walk, as comfortable in water as any marine mammal. Their games and sports incorporating the floods and tides that are now part of the rhythm of daily life. Transportation has been revolutionized by the expansion of waterways. Networks of canals, rivers, and coastal shipping routes connect communities around the world in ways that are both faster and gentler than previous transportation systems. Electric boats powered by solar panels and wind turbines move people and goods with minimal environmental impact, their silent operation allowing passengers to experience the peace and beauty of traveling by water. The air itself feels different in this transformed world, cleaner, more humid, more alive with the sense of growing things and moving water. The atmospheric circulation patterns that distribute moisture around the globe have created more stable and predictable weather, reducing the extremes that once made certain regions difficult places to live. The sound of gentle rain has become more common everywhere, a soft percussion that provides the background rhythm for daily life. As you drift towards sleep, imagine yourself in this transformed world. Perhaps you're lying in a hammock strung between the pillars of a house that rises above the gentle floodwaters of high tide, listening to the soft lapping of waves beneath you and the distant calls of seabirds settling down for the night. Maybe you're camping beside a mountain lake that didn't exist in your grandparents' time, watching the reflection of aurora-painted clouds and water, so still it seems like a mirror placed between earth and sky. The transformation is complete, and the world rests in a new equilibrium that speaks of life triumphant, of adaptation successful, of a planet that has found new ways to be beautiful, new ways to be abundant, new ways to support the endless creativity of evolution and the boundless resilience of living systems. In this world where all the ice has melted, where the waters have found their new level, where life has discovered fresh possibilities in every habitat, there is no catastrophe, no ending, no loss that is not also a beginning. The Earth dreams its blue dream, and in that dream, you too can rest, knowing that this is a world where change brings not destruction but renewal, not loss but transformation, not an ending but a gentle, flowing continuation of the ancient story of life on a planet that knows how to heal itself, how to adapt, how to become ever more beautiful with each passing season. Let yourself sink into that blue dream now, where the sound of water is always near, where the light dances on expanded seas, where life finds ways to flourish that we have not yet imagined. Rest in the knowledge that change, when it comes gradually and gently, becomes not a force to be feared but a current to be followed, carrying us toward shores we never knew existed, toward possibilities we never dared to dream. Sleep now, in this world of infinite blue, where every tide brings new gifts, where every season opens new territories for life to explore, where the ancient ice has returned to the sea that gave it birth, carrying with it the stories of every winter it has witnessed, every snowflake it has preserved, every moment of Earth's long, patient, beautiful history. The blue planet dreams, and in its dreaming, all is well.